Hello YouTube. I want to show you how to build a high quality water cooling system, which is something that I have created for this rather small HTPC case for my living room. So basically what we have here is an AlphaCool reservoir, which is attached to the top of the or actually the side of the case, and in there we have some slightly blue liquid. The blue color is actually left over from my old liquid, and it's not supposed to be there, but I would have to do quite thorough flushing of the system to actually get rid of that once I have used it. And as you can see, the tank is not filled all the way to the top. Instead, you always should have some airspace in there for pressure differences to kind of compress that air. If you fill it all the way to the top, whenever the temperature rises and the water expands, the pressure in the system will rise quite a bit, and that's not very good, because if you have anything that might leak, it's very likely to cause a leak. So always leave a little bit room for expansion. Alright, so this reservoir is actually a little bit modified. Originally the connectors were on the back side, because this is supposed to fit in CD-ROM slot inside the case, but in this particular case, first of all I wanted it to be external so that it's easier to refill using this valve, and secondly, you just cannot fit much inside such a small case, so definitely had to be external. And the connectors are normally here on the rear, but I had to drill another pair of holes for my own piping there. And the one on the bottom is aligned with the bottom of the reservoir so that it can suck all the water from the tank, even if the surface goes lower. And it's also right on the edge, so that if I tilt down the case to its regular position, it will still be on the bottom. The other pipe, which is in this case quite close to the pipe that is sucking, is actually the return pipe. And if you look closely, you can see a slight bump on the water on top of that, and this bump is caused by of course the water flow from that. If I had a more powerful pump, and believe me, I have tried quite many of them, this would actually go all the way to the roof of the tank. And on the other one, if you had a powerful enough pump, it would actually create a small vortex and start sucking in air to the piping, and that's definitely not something that you want. But I have in this system a very small pump, which is on purpose because it's actually quite enough, and even that pump was too noisy, so I had to undervolt it a little bit, but we'll have a look at that a little bit later. Alright, so that was for the tank, and on the other side we have a radiator that has some minor damage, but that doesn't really matter, and a couple of Noctua fans that are sucking hot air, well, not really hot, but air from inside the case, and blowing it through the cooler just to cool down the water. In case you were wondering, the piping connectors are on the rear, and the tubes go directly back inside the case. Alright, so before we go inside, I want to talk a little bit about supplies. First of all, when you're choosing your tubing, there are many options available, most of them plastic, but what this is a silicone tube, which is nice because it's very flexible and it will return to its original shape. this is not the case for plastic tubes, which actually when you heat them up they get very soft, but they won't retain the original shape. Also, I think this is 8 or 7 millimeters, but all my tube connectors are actually 10 millimeters. But because this is very flexible, it's really easy to fit this on, and it will secure quite nicely even without any clamping or anything. So always use a couple millimeters too small size, and I'm talking of the inner diameter here. So that's useful. The only real drawbacks of this kind of tubes are, first of all, if you bend it too tightly, it will at some point kind of like just go flat, and then it's a blocking tube. There's not going to be much or any flow through that. So keep your bends moderate, so that won't happen. And secondly, apparently the material leaks a little bit of water through the walls. It's not something that would make it become wet or anything, but it's the reason why we have to have a reservoir that has some spare, so that if you need to refill it maybe twice a year or something like that, that's quite okay. But that's caused by this kind of small leakage in the system, and it's just something that comes with the system. All right. Secondly, we have battery water. This is something that you should definitely use. This stuff is dirt cheap. You can get the larger canister for about 4 euros. They are available in supermarkets and gas stations, so take your pick wherever you want. The reason why we want to use this kind of water is that it prevents the growth of algae, which is something that if you just put tap water inside a system like this, there are going to be quite many organisms living in that water. It's definitely not clean, but there are small things living there, and if you circulate that in a nice and warm environment like a water cooling system, these things start to grow, and the system gets very slimy, and that's definitely something you don't want to do. Some people actually use poisons to prevent this kind of growth, but another benefit that you get from battery water is that it actually does not conduct electricity. It says here maximum conductance 15 microsiemens per centimeter, which means that it's highly resistive liquid. And in fact, I actually run measurements on this liquid, both brands, and both came up just 2 microsiemens per centimeter. So they are actually even much better than what the specification says. In case you were wondering, the liquid that I am using is actually battery water. Of course, there is a little bit of contamination from the old water, which is the reason for the blue color. But I made a measurement of that liquid, and it came out at 30, so it's actually quite good still, and reasonably non-conductive. So I think if this would leak inside my system, and you always have to be prepared for this kind of leakage, because it just happens sooner or later. But if it would leak, I don't think it would even crash my computer or anything. Things would just work normally, because it's so little conductive. If you compare that to regular tap water, which is about 160, at least here when I measured it, so having just 1/10 of that basically is what you, or even less with battery water. So that's definitely going to be much better. All right, so that's it for the externals, but let's go and have a look inside. Alright, before we go inside, another look at the tank. This is actually the natural position that this system is supposed to be used in. And here there is a wall in the middle, but a gap here. So basically, if there would be any air in the system or in the tank, the air bubbles would come up here, climb to the other side of the wall, which is actually quite helpful, because now if I would shake this box or anything, the air will stay safely on this side and not in any circumstances reach the pipe here and get into the circulation, because that's something that you really want to avoid. You want to get all the air out from the circulation and to the reservoir. All right. So I had opened the screws before, and now we are inside. So what happens here is the tubing from the tank goes through to the bottom of the power supply, and then there's some piping that you cannot see from here unless I remove the power supply, but it comes from here and goes to this blob of, as you may have guessed, it's Blu-Tack. And this is actually my pump that is inside. I have a very small pump, but for noisy insulation purposes I had to put it inside such a huge blob of Blu-Tack. Alright, that's actually 2 full packages of the stuff, in case you were wondering. And from the pump it continues to the GPU, where we have a water block that I had to manufacture myself out of copper pipes, pieces of solid copper, and some soldering tin. This is actually a pretty neat technique. You can manufacture these things on your stove. Just use a boiling plate and put your pieces of copper on top of that and start applying tin to the wherever you want to attach these things. And when the parts are really hot, the tin will simply suck itself into the small openings, and you get very good connections just that way. You just have to use a lot of tin so that the seam is wide enough for heat to be conducted properly. And you can even do watertight junctions, as is the case in these ones. But you can also, if you prefer, you can avoid that by just using one pipe that has a U-turn, and then you don't need to make any kind of connection except with the tubing. But as I said, if you're using silicone tubes, you can simply plug them over the pipe, end of the pipe, and it will seal automatically. So there you don't need to use any kind of clamping or anything. The reason why I had to build my own is that all the products on the market seem to be of the same shape. They are higher than this, and they have the pipe connectors coming over the card. And as you can see, my case is too small. There simply isn't any kind of room for anything to come above the top of the GPU. Actually, even the power connections, which in this model come upwards, they don't really fit very well inside this case, but I can manage to close it. So that's kind of enough. Alright, and from the GPU, the flow continues over here, and to the CPU block, which is something stock made. A pretty basic CPU block with 2 tube connectors. Once again, no clamps, just the tube plugged in, and that's it. Alright, and from there it continues to the outside of the case, to the radiator, and then back from the radiator, and finally back to the tank. So that's for the circulation. And this kind of connection is actually quite useful, because or the thing that you would normally do. First you have a reservoir, which has to be, at least when the computer is in the filling position, it has to be higher than your pump, so that when you start adding water, it will come down and enter the pump, because pumps cannot pump air, they will only pump when there is water inside the pump. So you have to have the water enter the pump by gravitation or other means, and gravitation here is the easiest one. And when the pump is full, it will happily pump all the rest of the air from the system away by pumping in water. And basically this is designed so that air will be mostly going upwards. It starts from the bottom, goes to the CPU upwards, goes even more upwards. Of course this part is pretty high up, so it will have to come down a little bit before it gets back to the tank. But this kind of setup is very efficient at filling the system and getting the air out, which is the biggest problem really with water cooling. Alright, so speaking of this noise insulation thing, you want to be able to insulate both vibration, which is a pretty big problem with water pumps, and actual audio, the kind of audible noise that the motor itself makes. And whenever you want to insulate vibration or audio, the primary thing to consider is that you have to have separate layers of dampening layers and insulating layers. The dampening layers are some soft material. It could be foam, it could be, well, as in this case I have actually used a wool sock from my grandma. She kept sending those me like every Christmas or so, and I have never used any of them. But finally, when I started building water cooling systems, I found the perfect use for them. I can just put them around my pump and sometimes reservoirs, and to kind of have them dampened that way. And dampening on the outside won't do you any good. You always have to have an insulating layer, and this is where the Blu-Tack comes in. I could have used some hard case or hard material for that, but this was assembled quickly and I didn't want to bother with that, so I just took a couple of sheets of Blu-Tack and kind of twisted it all around the thing and made it reasonably airtight, which is kind of crucial for insulating audio. And this seems to work very well, because you probably cannot hear pretty much anything from the computer is fully running. It's working at the moment, but I'm pretty sure the only thing you maybe can hear are these fans, and these are actually very silent anyway. Alright, and in case you were wondering about the plastic, this is just to protect other parts from coming dirty. I put that between the sock and Blu-Tack, and also around the Blu-Tack, so that things kind of stay clean. Alright, and additionally, just to add another layer of insulation, I didn't let this blob touch any part of the case, but instead I tried to connect it to the tubing and to the wires and so on. So it will stay in place, but it has another layer of dampening here before reaching the outer casing of this case. So this in total gives me very noise-free computer, which is kind of important here in the living room. The pump itself, even though it's insulated this way, still make some noise if run regularly, but fortunately this model connects the motherboard fan connectors. This is an AlphaCool pump, by the way. It connects to, well, one of them, which cannot really be seen properly from here. And using that connector, the motherboard will adjust the speed of the pump based on the CPU temperature, just as it would adjust the speed of the fans, and actually as it even does with these Noctua fans. So at the moment this computer is not doing much, so the CPU is quite cool and everything is running silently. If I'm running CPU burn, I can actually make a little bit of noise, but it's still much quieter than anything that you would normally get in an air-cooled system. So okay, that's pretty much it. Well, one more thing that I want to mention is that the power supply is Seasonic. I only ever use Seasonic because well, when you buy Seasonic, you know you will get a quality device. If you buy some other brand, you usually don't even know who has manufactured the unit. It could be Seasonic, it could be some other company. But when you are buying a Seasonic brand unit, well, you just know that you're getting the highest quality parts. And that's kind of important for me, because I don't want to waste my time trying to find out which hardware is being used in which unit and so on. And this is the X650. It's a little bit older model, but I think it's still available. At least the X660, which is pretty much the same thing. And what's cool about that for a water-cooled system is that it's a semi-passive unit. So it does have a fan, but this fan is not running at all normally. Only if this unit gets hot enough, it will start the fans or the fan. And I don't think this pretty much ever happens on my system. So basically what you have here is a passive power supply. And this is something that you should really consider for a water-cooled system, because there's no easy way to connect the power supply to your water cooling system. So definitely try to find a way to get the one that doesn't need a fan. And speaking of that, another problem that has been a really big problem until recently are the motherboards, because there are some parts that get really hot on the motherboard, and sometimes they have their own fans which are always very noisy, or as in this case they are just heat sinks. But if you have a little bit older motherboard, you mightn't have, they are designed to work with a CPU fan blowing around here. So they expect to get that extra cooling from your CPU fan, and if you don't have that cooling, then it's going to overheat and your motherboard might be crashing or something. So if you have an older motherboard, it might be safer to put an extra fan inside here just to blow the air a little bit around these heat sinks. Fortunately, the latest generation, this is Gigabyte Z77, and this generation doesn't even get, it's not really warm at all. If I touch here or here, it's pretty much the same temperature as my finger. So the design of these parts has improved so much that it's not really a problem anymore. But it definitely was a year or two ago. Alright, that's it. Hopefully you got some pointers for how to build a good water cooling system. And if you are building something like this is my own invention. I have seen a few other people build this, but I definitely want to hear and see pictures if you are if you are making any of these, because it's kind of cool concept, something that you can really easily make at home. So if you just kind of get copper pipe and pieces of copper, it won't work with some other materials, so copper might be the safest to use. And when you're manufacturing this, copper will corrode when it touches air. So if you want to keep it shiny, like I have kept this one shiny, just add a little bit of spray varnish on top of your finished unit. I actually added some even on the bottom that touches the GPU, the chip down there, because the layer is so thin that it doesn't really make any difference. So yeah. All right, that's all. Bye.